Hi, this is Arun Kumar Paintikar and I am a team leader of the project, and currently we are doing a final year project which is based on wind speed prediction. Our project titled as Explainable Artificial Intelligence Based Wind Speed Prediction System. So coming to our project, this is our project. We have wind speed prediction system here using the wind weather parameters such as temperature, humidity, pressure, wind bearings, visibility, cloud cover. We are going to predict the wind speed by not only based on these weather parameters. This is the front end part. We are going connected it with the back end part using the AML, and we written the code over there using explainability like shape and line, and we are used the data set over there of which contains 96,000 records of all these weather parameters. So we train the model, and based on the model we are going to have a fast API in between the front end and back end part. So these fast API delivers the parameters to the front end using the back end. So we used Python for the back end, and for the front end we used Vue.js like React, TypeScript, etc. So now, as these features based on these weather parameters, we are going to predict the wind speed. So what is the main purpose of predicting the wind speed? The wind speed prediction is mainly useful in the power energy generation and for the current circuits, and all these things are going to happen with the wind speed detection. So we are now predicting the wind speed based on this. So when we are clicking on this button, this is redirected to the backend part, and it can be tested with the backend part, and using the fast API we are going to predict the wind speed. So the wind speed prediction is said to be like 11.18 meters per second, and we categorized that the wind speed is moderate or high or low, like low, medium, high. We are going to calculate, no, based on these features the wind speed prediction is moderate, and we are going to energy estimation. So the main part is wind speed prediction is for the energy estimation. So here you can see that 42,786 watts energy estimation is going to happen based on this wind speed prediction. So this is the main dashboard which we are dealing with. And second one is explainability. Like all machine learning models are like black box models. For example, when we take any machine learning model like logistic regression or whatever which is present in the current market, is like having they said that the wind speed prediction is only so and so like 11 parameters or like 11 meters or etc, but they don't able to say like why this going to happen. So now our main project is that we are using the shape explainability. So based on this explainability we are going to analyze, so based on these futures how the graphs are going to happen. So now you can see the future contributions. So here you can clearly see that humidity, day, wind bearing, visibility, hover, cloud cover, temperature, pressure of all these future combinations. These three features, what you can say, the day, wind bearing, and visibility. These three features having the positive sign of wind speed prediction, and these the predictions like humidity, hover, cloud cover, temperature, pressure. So that you can see that based on the humidity, only the wind speed going to vary majorly, like major drawbacks or major comebacks are said to be happening based on the humidity only. So based on it we can have that how much humidity can affect on the wind speed, and how much day can be affect on the wind speed. So these features, like all these features can be predicted on the normal ML models using the normal what you can say chart.js etc, but we are contributing it to a front end so can explain the project easily. Our main target is to explain a project to the non-technical users also, so that we are dealing with this shape explainability. And coming to another tab, historical data, we can here have a feature called upload CSV file and load demo data. For example, if we load demo data, you can see that what is the actual wind speed predicted. Now, based on our features, like what we have uploaded, based on these features, we are going to have a low demo data. Said that using 50 samples, we are going to have like this type of mean value and this type of predictor value, and maximum minimum error is that, maximum error is that. We are going to have some like graph a temperature to temperature for sample to sample we are going to have it, and what is the prediction errors we are going to maintain a chart for it. So not only using the demo data, we are going to have a CSV file over there using weather history data also we can upload that. So based on that you can see that the graphs are going to change at every time. So this is a real time CSV integration to a front end to a back end part. So we are dealing with it. So every time, every minute, and every second, we are going to predict like what are going to happen. So major project is we used like three models, which is a linear regression, random forest, and XGBoost. Like why we are going to have these three models is that the linear regression is a normal and the static method for the regression models, so that we are having like it is a base model, and random forest is a combination of mix of some models, so we are going to deal with the random forest, and XGBoost is the advanced model. So we train these three models on our data set rigorously and use the 80% training data and 20% for testing data. So based on these two features, we are going to calculate the R score value, mean absolute error, and root mean square error. Based on these three features, we are after the rigorous trainings and after testings and after the of all these things stuff, we are predicted that XGBoost model is going to have a better comparing to all these models. So we predicted this plots using that what is the R2 value for linear regression, random forest, and XGBoost, and all of this stuff. So based on our model comparisons, we came to find that XGBoost is the one of the best model to use with. And not only this model, we can train the many models for our project also using the CNN models, LSTM, BERT, all these models, advanced steps, not only for the limited to ML models, by combining the like linear CNN models we are going to have it. And we are going to move into next session is the generate report. Of all this, what you can cover the dashboard, explainability, historical data, model comparison, we can get all through this a report using the temperature, humidity, pressure, wind bearing, visibility, cloud cover. We can generate and download the report. What the report contains? The report contains the input weather parameters. You can see that the report is downloaded. Predictive wind speed and risk assessment, wind energy estimation, shape futures, visualization of graphs. So this is our project description about a wind air project. So what make us to do this project is that normal wind speed predictions, just they in the market they say that they use the normal raw data, and just they said that they doesn't have any code back. They want to deal with the normal tech stack and they can do, but we here use a front end combination of the Flask API, and we use the front end part. So based on these three combinations, we predict the wind speed prediction. This is the IEEE paper format for the publishing. And using that mean our core feature is that shape explainability. Explanation is the main core part of like what is going to happen. You can normal uh in that normal chart GPT, like what you can say that they didn't give that, is it give a text format only, but you can have pictorial representations also. In the ML model we can't have like these features. So that our project we mainly aim to show the explainability how like what is a major factor and what is going to have a major drawback, and what is the historical data. Like you can see that based on these graphs only we said here sample 50 data, but for the thousands of data also we can going to have like whatever can change it. And again the model comparison also going to have all this. So in this project, like our team members like myself, Arun Kumar, and Sujan Kumar, Dinesh, and Parmeshwar Rao has built all this project. And coming to our guide, Dr. Amit Kumar Yadav, we are thankful to our guide predicting this, and he helped ours by giving the best quality suggestions to how can we proceed with the ML. And we are dealing with the ML with the core front end and back end part. We are having as a team, we are managed to build all this. And thanks to SR University, thanks to our project guy, and thanks to our reviewers like who made all these kinds of stuff. And and this is all about our project. Thank you.